What is going on, everybody, and welcome to the second part of the Q learning algorithm. We had just left the previous tutorial, in the verge of creating the Q table. So now the question is, how do we create the Q table? So let's just get back to PyCharm and let's just calm this out for a while now. Yeah, no pun intended. Okay, so I'm just gonna clear that out. Yeah. So first of all, let's get a few things cleared out here. So let me just print these values for now. Env dot observation space dot high, and I'm just gonna duplicate that and gonna print this low, and also the number of action space you have, right? So I'll just explain what all this means, and yeah, I'm just gonna run that. So what do we have here? So as you can see, it's printed out the observation space, high and the low value. So this means that our environment, our particular, the mountain car environment, has a high of zero point 0.6, right? And a low of minus a negative 1.2. Yeah, so what does this mean anyway? So this is the amount of value that the given environment, the maximum value of the environment can be, right? So in essence, that if we reach the goal, right, so we could think of it and we could give this value, and if we don't, we can give any of these values, right? And the action space, so action space, as the name itself is trying to suggest, is the number of actions that you can take in this particular environment. So these actions are either go right, go left, or do nothing. So these are the uh, different possible actions you can take in the given environment. So yes, how is this going to help us to create, excuse me, the Q table, right? So yeah, the question is, how do we create the Q table? So let me just run let me just show you an example of what the Q table would even look like, right? So I'm just gonna open up a Python console, and don't mind me, but I'm just gonna copy this, and I'm just gonna, right. So now let me just show you the Q table view as an array. Right. So this is how the Q table is going to look. Um, and by the way, so if we see this, I'm sorry. Yeah. So what we will essentially do is we will try to create a like a 20 by 20 and two dimension of 20 rows. So let me just show you what I mean by that. That's essentially the Q table which I'm trying to show it to you, right? So here you can see we have about 0 to 19, so which are totally 20 rows, and each row contains the Q value. So you can, this is essentially the Q value, right? These are all the Q values, and this means these are the actions here, right? So you can think of this as, the columns are essentially telling you the actions, and the rows are giving you the particular Q value for that particular action. So if you're trying to analyze, the zeroth action here has a Q value of minus negative 0.93, and the action 1 has a negative 1.9, and action 2 has a negative 5. So right off the bat, you can see the action that would be taken should have the maximum Q value. So since they are all in negative terms, the maximum value here is negative zero point 0.5, right? So the action 2 is going to be selected, and we can sort of fine tune this queue table and in multiple iterations. So in terms of queue learning, we call iterations as epochs, sorry, episodes. We call in the classical deep learning machine learning, we would say epochs, whereas here we would call it as episodes, where you sort of keep iterating through those number of episodes. And usually those episodes value will be more high, depending on our environment and the q values. So these are the q values which we'll have. And let me just print out, if we print out, I had shown you the reward, right? So let me just undo this while and let me print that out. Let me print the reward and the observation. um, no, just the observation, right? Let me print the observation. uh, Oops, I've forgotten to write env dot close, right? So I'm just gonna run that, and you can see these are the different observations, right? So if I say this these are sort of the xy coordinates in a two-dimensional space. You can think of these are the xy coordinates, and these are the different observations which we'll be requiring, right? So in essence, we are trying to create a queue table. So how are we going to generate a queue table? So essentially how this works is, initially we will create a random queue table, random valued queue table, where these values don't really matter in the beginning, as the agent will sort of try to figure out and update the queue values on its own, right? So that is what we are essentially going to do. And so what we'll do is we'll sort of delete the unwanted space. Yeah, so we will try to create a queue table which is of 20 by 20. These are all sort of the hyper parameters you can think of, and this sort of changes uh, for a different environment. So we'll try to make it robust and hope that it would work in different environments as well, right? Because this is something like, this is a model free learning, so this is not entitled only to this environment. It should be adaptive enough for different environments, right? So we'll create a discrete observation size, ret discrete observation size. So that would be, sorry, observation space size. So these, let me just create a discrete observation space size, so which will be of 20 times the length of any of the observation, right? So let me just do that. So essentially what we'll end up getting is a 20 by 20. So that's a two-dimension list which has 20 rows, uh, as we saw where you know it has like 0 to 19, which are 20 rows, and three columns, as they are the actions that are to be taken based on the q values, right? So initially we will sort of set up a random q value in the q table, right? So that is what we are trying to achieve. And this value is this again a tunable value. You can always fine tune the value, and essentially you will not even know the high and low for the environment. If suppose you are creating your own environment, right? And what happens is you wouldn't know what is the high and low observation space. So sort of Jim is sort of gracious enough to just throw those information right off the bat. So everything is like a trial and error here, so we can try to figure that out. But I've seen this works, so let's just stick with that. And we'll create a discrete observation space window size as well. um, discrete discrete OS window observation size. So essentially these are the values. We will try to divide these discrete, as you saw our, we had, right? So these are sort of continuous values. Like we have to try to figure out some discrete discrepancies and try to find the discrete values amongst them, right? So that is what we are essentially trying to do. So m dot observation space dot high minus dot observation oops observation space dot low. So what we are essentially trying to do here is, let me just print the observation, and for now I'll just, and let me just run this. Right, so now what we are doing is essentially we are taking the high minus the low, and since we want it to be divided by, we want 20 discrete values, we will divide that by a discrete OS size, so which is a 20 by 20. So what we are trying to do here is, right, and we'll divide that by a 20 by 20. So this is what we are trying to do, right? So we are trying to take the high minus the low value and trying to make it discrete for 20 values, right? So we have a 0.09 till 0.007. So this is what we are trying to do. And how do we create the Q table? Now we can do this. So the Q table would be equal to np dot random. Oops, I think I haven't imported np. So import numpy as np. Right, so np dot random dot uniform. So what this uniform function does is it takes a low, and we'll start off from a -2. It takes the high, and we will give it, as I said, if the agent achieves to reach the goal, he'll get a value of 0, right? So we will give high equal to 0, and size is basically our discrete OS size plus the number of action space we have. So number of action space is env dot action space dot number, right? So number of action space. So what this creates is a Q table of 20 by 20 plus 3 dimension, right? So we are trying to create the Q table like that. Let me just open a Python console and let me just run that there. All right, so I'm just going to run this. So now you can see the Q table is being created, the random Q table, right? And what this uniform function does is it tries to give the same preference, or the probability of selecting a value will be equal. So that's what uniform is trying to do. And it takes a low and high and the zero. I mean the size. Sorry, the size. So this is what it is. And now we have successfully created a Q table. Uh, but these are just random values that have been created between -2 to 0. So we have to sort of make the agent explore the environment and optimize these Q values. So, and once he starts exploring and exploiting the environment, we can we can create the we can create the Q table and update the weights, update the values. Sorry, not weights. We can update the values. This is if you can try to sync again. This is almost like back propagation. trying to minimize the loss function. So now we have successfully created the queue table, and in the next video we will see how to train the agent and come up with a new try to update the queue values, right? So we will check that out in the next tutorial. See you next, guys.